So in this concept, we're going to learn about solving equations. And the goal behind what we call solving equations is to essentially determine a value for the variable or variables in an equation. Okay, so the main thing you have to do is isolate the variable to one side of the equation, and you do that and whatever's after that by moving the variables and numbers around from one side of the equation to the other side if necessary. Okay, so you can add the same term to both sides to move it from one side to the other, or you could say that I'm going to move this term from this side to the other while switching the sign. We're going to look at all these techniques shortly. Okay, let's look at an example. So solve for x. 6x plus 2 equals 2x minus 8. So this is clearly an equation having one variable, x. The goal is to, like we mentioned, is to isolate x to one side and then just get x to equal something, and that something will be the solution of the equation. So what we could do is bring the x's on the same side and then bring the constants, the numbers that don't have any variable with them, to the other side. So what we could say is there's two ways to do it. So you could say I'm going to bring the 2x on this side with a negative sign, or you could say I'm going to subtract 2x from both sides, right? Both these techniques give you the same result. So, and why do they give you the same result? Well, because here you're going to have 2x minus 2x, which is 0, and then you'll end up with 6x minus 2x, and then plus whatever's left on this side, right? So personally, I just do the technique where you say I'll bring whatever term to the other side, and then just flip the sign. It just feels quicker in the flow of solving the equation. So let's try that. So 6x plus 2 equals 2x minus 8. So we have 6x, so we're going to bring the 2x to this side with a negative sign. 6x minus 2x, right, and then the plus 2, right here, equals negative 8, right? Now I have the plus 2, I'm going to bring it to the other side with a negative sign, right? So I'm going to have 6x minus 2x equals minus 8 minus 2, right? Which is exactly what we have here. 6x minus 2x is minus 8 minus 2. Then we're going to combine like terms. So 6x minus 2x is 4x. Minus 8 minus 2 is minus 10. So now we have 4x equals minus 10. I still need to isolate the x, so in this case I would divide by 4, right? Divide both sides by 4. So these cancel out, minus 10 over 4, right? So x equals minus 10 over 4. Okay, you can simplify this further, right, using the greatest common factor, because this is an improper fraction, and you would end up with minus 2 halves, minus 2 and a half. Okay, there are three major types of answers for an equation. You can have an equation that has only one solution, a single solution. Here's an example. X plus 2 equals 5. There's one solution that's going to work with this equation, or that's going to fulfill the answer for this equation. Okay, and the way to find that is, again, so you would need to isolate the x, so you can bring the 2 to the other side with a negative sign because it's positive. So you would have x equals 5 minus 2, which is 3, right? So x equals 3, which is exactly what we have here. Okay, and that is a single solution. You can have equations that have two or more solutions. Okay, even up to infinitely many solutions. Here's an example. So solve 5 parentheses x minus 2 plus 15 equals 5x plus 5. So order according to the order of operations, right? So in this case, we want to get rid of the parentheses, so we just multiply out the 5 times the x and then the 5 times the minus 2. So we get 5x minus 10 plus 15 equals 5x plus 5, right? Which is exactly what we have here. Distributive property, using the distributive property, and then combining like terms, right? We just combine the numbers. So minus 10 plus 15 is plus 5, right? And then we have 5x, so 5x plus 5 equals 5x plus 5. We can combine like terms, in which case we would have 5x minus 5x, right? So all we did was bring this to the left side while opposing the sign, right, with a negative sign, and then bring this 5 to the right side with the opposite sign, right? So 5 minus 5, right? So you get 5x minus 5x equals 5 minus 5, which essentially gives you 0 equals 0. I mean, it seems pretty obvious, but what this really means is that this equation has an infinite number of solutions, right? The solution essentially is all the real numbers, because anything you put in for x here, whether it's 1, 2, 10, 20, 100,000, will make the equation true. Okay, will make the equation correct and true. You will still get 0 equaling 0. As obvious as it may sound, but it will be logically and mathematically true. So that's why the solution is the set of all real numbers. So there's an infinite amount of solutions. And lastly, you can have an equation that has no solution. Let's look at an example of that. So let's distribute, right? So you're going to get 2x minus 6 plus 10 equals 2x minus 5. So minus 6 plus 10 is plus 4, so you're going to get 2x plus 4 equals 2x minus 5, right? Right here. If you combine like terms, you end up with 2x, so you can bring this 2x to this side, right, while bringing the 4 to the other side. You're going to end up with 2x minus 2x equals minus 5 minus 4. 2x minus 2x is 0. Minus 5 minus 4 is minus 9. So is 0 equal to minus 9? Of course not. So there is no solution to this equation. Or the solution, you could say the solution is the empty set, okay, or the null. Okay, there are no numbers, or there are no solutions that make this equation true. Okay, that's another way to say it. Here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, let's look at this first equation. So solve the following equations. Minus x minus 3 equals minus 5. Again, the main goal to begin with is to isolate the variable on one side of the equation. In this case, you could take the minus 3 to the other side while changing the sign, right? So positive. So you'll have minus x equals minus 5 plus 3, right? Because you had minus 3, you brought it to the other side, so you have plus 3. Alternatively, again, you could have said, I'm going to, you want to get rid of the 3 on this side, so how do you get rid of well, it's minus 3. How do you get rid of minus 3? You add 3 to make it 0 on this side, but then here you would also have plus 3 to keep the equation true and valid. So it's the same. Pick your technique and just stick with it. My preferred method is to say I'm going to bring it to the other side and flip the sign. Okay, you may choose to do the addition, you know, just as a sanity check, if that's the way you'd like to work. That's fine. But either way, you end up with minus x equals minus 5 plus 3, which equals minus 5 plus 3 is minus 2. So minus x equals minus 2. Look at that. Again, I could say that, well, the negative signs cancel, right? Because there's a negative sign here and a negative sign there. So this would be the same as x equals 2, right? Or I could also say I want to get rid of this negative sign, so let me multiply by minus 1. In which case I'm also going to multiply this side by minus 1, right? So minus x times minus 1 is x. Minus 2 times minus 1 is 2, right? So you still end up with x equals 2. That is the solution. Number 2, equation 2. Minus 1/2 x minus 1/2 equals 3/4. So again, the goal is to isolate the x on one side. So you could say minus 1/2 x equals 3/4 plus 1/2, right? So all I did was I brought the minus 1/2 to the other side with a positive sign instead of the negative, right? So 3/4 plus 1/2 is 3/4 plus, so what's 1/2 in base 4, in a denominator of 4, I'm sorry? It is 2/4. So 1/2 is 2/4, right? So I end up with 3/4 plus 2/4 is 5/4, right? So writing the equation again, I have minus 1/2 x equals 5/4. Now, in this case, it may seem a little tricky because you say, well, you know, do I divide to get rid of this 1/2? You know, again, the goal is to isolate the x by itself. So do you divide, do you multiply, do you subtract? Well, of course you don't subtract or add, right? Because this, you know, it's 1/2 times x, or minus 1/2 times x. So in this case, you could say, you know, so you have 1/2 x, right? You could say I'm going to multiply by 2, right? Which, what does that do? So 1/2 x times 2 is, the 2 cancels with the 2, is essentially 1x, right? Which is just x. So you could say you're going to multiply by, well, let's make it negative 2, because again, remember, you still need to get rid of this negative sign, right? So minus 2 cancels out, so you get positive, and then minus 2 minus, or 2 and 2 cancel out, you get 1. So you end up with x, right? And on the other side, we have 5/4 times also minus 2, right? Remember, because that's what we did on the left side. And you could say, you know, divided by 2 is 1, divided by 2 is 2, right? And then, so it's 5/2. So it's 5/2 times negative 1, right? Which is negative 5/2. So x is negative 5/2. Next exercise. So we have 3x minus 4 parentheses x minus 2 equals minus x plus 8. So again, order of operations is to distribute the coefficient to the parentheses. So 3x minus 4x, and then minus 4 times minus 2 is plus 8. So minus 4x plus 8 equals minus x plus 8. Combining like terms, you get 3x minus 4x is negative x plus 8 equals negative x plus 8. Well, something equals itself, right? I mean, you have the same expressions, you know, the one expression equaling the other expression, but they're essentially the same expression. So again, the solution to this is the set of all positive numbers, or of all numbers, right? The solution is all real numbers. So there's infinitely many solutions. So any real number you put in here will make this work, right? Last exercise. So 3 times parentheses 2x minus 1, and then the whole thing minus 1, equals 6x plus 4. So 3 times 2x is 6x minus, so 3 times negative 1 is minus 3, minus 1 equals 6x plus 4. So 6x, so minus 3 minus 1 is minus 4, equals 6x plus 4. Well, so this one looks kind of interesting, right? I mean, even before you go further, how could something, you know, minus some number equal that same something plus that same number? So you know it's not going to end up having any solutions. But let's just go ahead and try to combine, you know, the like terms and the like variables and all. So I can bring this xx to this side with the opposite sign, so to make it negative, and then I can bring this minus 4 to this side with the opposite sign, which is plus. So you end up with 6x minus 6x equaling 4 plus 4. So 6x minus 6x is 0. Again, pretty obvious, but it is mathematically correct to say that this equation will not have any solutions, because in the end you have 0 equals 8. Okay, this solution is not mathematically correct. 0 is not equal to 8, obviously. Okay, so the solution here is the empty set, or we say there's no solution. Okay, that's it for this concept. See you in the next video.